A topic from trigonometry that's considered to be pretty important is the law of sines. This is a formula basically that you can use to answer questions like I have up on the screen here, 3 typical law of sines questions. Number 1 is a question where we know 2 angles, we know one side, we don't know one of the other sides there across from the other known angle. Question 2 is one where we know 2 sides, we know the angle across from one, and we want to know the angle across from the other, and we can see from the picture that we want to have an obtuse answer. And then the third question is one where you're given, and this is a typical standardized test question, not my favorite to teach at all, but it is something that comes up, where you're told some piece of information about a triangle. You're told an angle, you're told the length of the side opposite that angle, and you're told this other side. And it's something called the ambiguous case, is where you have to determine whether it is possible to make a triangle under those conditions, or is it possible to maybe make only one triangle, or possibly 2 triangles. So when a kid goes to Khan Academy to figure out how to do their homework on the law of sines that they just got, they're going to be expecting to see some worked examples. Well, Khan Academy is a bit inconsistent in this way. Sometimes they have topics where they just show how to do it, and for some kids that's actually okay. Sometimes they just want to know how to do it. That's why they're in a rush. They go on the internet and they want to know how to do it. And sometimes the understanding does come later. So I don't have a problem with some sort of skill-based lessons just to get the kids on their way. Some lessons have both the explanation and also some worked examples. But in this case, this law of sines lesson just has the derivation in an abstract way and nothing else. So I'm going to take a look at that. So I'm going to speed this up to triple speed, so the whole video takes about 2 minutes. This is a very standard way of proving the law of sines, and it's a fine proof. But this is it. This is all that's going to happen. We're going to have an abstract proof with A, B, alpha, and beta. That those Greek letters might intimidate some kids. Just observation. But they'll never be. I shouldn't say they'll never be, because I hope that by seeing this video, people at Khan Academy add the logical next video, which is some worked examples of how to apply the law of sines on a test. They're not going to be, well, they could be asked to prove the law of sines, but most likely they're going to be asked to apply the law of sines, and this just never goes there. It's sort of a false promise. Very easy to correct, just add another video, applications of the law of sines. But what concerns me is how they didn't realize this. This is an important topic. Most standardized tests have some question involving the law of sines. It's a very cool formula. It has a clever proof. It's useful. You can use it to find distances of things far away with indirect measurement. It's just a good topic all around, and I'd say I spend 3 days on it when I'm teaching it in my class. So in this 6-minute video where the formula is derived in this abstract way with no application, it just puzzles me. This video was watched on YouTube 90,000 times, and I don't know how many times on the Khan Academy, but I don't think that they're really checking to see if kids are learning from this, because I don't think many kids who don't know this already would be able to apply the law of sines after watching this video.